the drummer kick, let the drummer kick die. Let the drummer kick, let the drummer kick die. Let the drummer kick, let the drummer kick die. Let the drummer kick, let the drummer kick die.
The Snoqualmie Falls were produced during the deglaciation period of the Cascade Glacier. A moraine had been formed near Snoqualmie Falls within the Snoqualmie and Cedar Valleys, consisting of pre-Vashon Age glacial drift. It caused the derangement of the Snoqualmie drainage, producing Snoqualmie Lake. This was then bisected by the alluvial fan delta of Toco Creek. On draining or filling the lake, the trunk Snoqualmie River coursed around the edge of the delta and superposed on a rock ridge of pre-glacial South Valley side, which is what we know now as Snoqualmie Falls. This is a geologic map of Snoqualmie Falls. Snoqualmie Falls is on the Snoqualmie Valley Fault and close to the Rattlesnake Mountain Fault. It's within a U-shaped valley rather than a sharply V-shaped valley, which coincides with the area having been glaciated. In the upper right, you can see where the Toco Delta now lies and how that would have helped in creating the falls when it was further west. You may also notice that the falls is located almost directly on a syncline in a downward plunge, which is denoted by the purple arrows pointing inward on a line. The darker yellow denotes landslide deposits from the Holocene to late Pliocene period. These deposits are poorly sorted, non-stratified, silty, sandy gravel, and clay mixed with cobbles or boulders. It also contains sandstone and siltstone. This is a greenish-gray or gray and weathers yellow-brown, containing plagioclase, augite, hornblende, and quartz. This composition fits well with this first outcrop observed, which is made up of a non-stratified dark brown sandy coarse-grained texture, which was crumbling, easily broken. In fact, it was very similar to the texture we saw at the Renton Formation. I would hypothesize that this formation is made up of sandstone, clay, and gravel, the clay possibly due to the chemical weathering process of hydrolysis, as there was a constant misting on this outcrop. These deposits were placed there when a large ice tongue melted to fill the lake, which is thought to have been quite stagnant, also filling it with bedded silts and clays, as well as the glacial Toco Creek had built a sand-gravel delta which bisected this area. I noticed a slight yellowish rust color on part of the face of the formation, which I would attribute to oxidation. Another observation was that the upper left side seemed to overhang the right side on the outcrop. This could be due to the presence of water in the formation from the misting, which would reduce the internal friction between the grains as well as create an added weight to the sediment, causing it to slide down, leaving the more stable overhanging piece of the outcrop still intact. The several lines of breakage in the outcrop could have been due to the mechanical weathering process of frost wedging, with cracks such as this quite common due to such a big presence of water. It is also quite known that the climate of this area is quite cold during the winter. The salmon pinkish color surrounding the falls marks tertiary volcanic, intrusive, and sedimentary rocks. The site contains a lot of andesite flows containing plagioclase, augite, and biotite, as well as a lot of breccias and laharclase, which are compositionally quite similar to the andesite flows. The map also indicates that the area consists of volcanic rocks of Mount Persis from the Eocene period, stating that basalt is very rare. However, recent discoveries have uncovered that the falls is actually only 1,000 feet away from a 20-million-year-old faulted volcano, and that tertiary basalt is actually quite common in this area. This outcrop was made up of dark gray or black mafic rock. It was not easily breakable or brittle, and I would hypothesize that this rock is extrusive volcanic basalt containing minerals such as plagioclase, pyroxene, olivine, and amphibole. The outcrop was made up of slabs of this rock about an inch or two thick that were nearly vertical, though angled slightly towards the right. I would hypothesize that this is due to joints and that the cracks form parallel to the surface as sheeting. They are then uplifted, eroded, and perhaps mechanically exfoliated in the process of frost wedging. This would remove the confining pressure of the overlying rock layers. Thus, the rocks are able to rebrown and break into slab-like layers. In addition, if this formation had been on an angular unconformity, although the sheets had been deposited horizontally, it would explain the outcrop having been tilted to a near vertical position. There is also a red color in some of the rock, which is probably due to the chemical weathering process of oxidation, which would coincide with the iron-rich minerals that make up basalt. The outcrop was observed to be about 6 feet tall by 8 feet wide. Today we know Snoqualmie Falls to be a 268-foot cliff located in the northwest region of Washington State, just 30 miles southwest of Seattle. It began as a popular tourist attraction in the 1850s and remains one today, as Washington State's second most popular tourist attraction next to Mount Rainier.